Graph of polynomial function. Consider the function f(x) equal to x cubed minus 3x squared minus 12x plus 8. We want to find the interval where f(x) is increasing or decreasing, hence determine the extremum point. Find the interval where f(x) is concave up or concave down, hence determine the point of inflection. And lastly, using all the above information, we want to sketch the graph of f(x). So A, we are asked to find the increasing and decreasing interval. To do that, step number 1, we must differentiate the given function. So f prime x equal 6x squared minus 6x minus 12. We can simplify x squared minus x minus 2, factorize, we get x plus 1, x minus 2. From factorization, we can get the critical values. So x equal negative 1 and x equal 2. From the critical values, create a table of 3 columns. First column for interval, second column for test value, and third column f prime x. For interval, always start from negative infinity and ends with positive infinity. In between, arrange the critical values starting from the largest until the starting from the smallest to the largest. So first interval from negative infinity to negative 1. Second interval negative 1 until 2. Third interval 2 until positive infinity. Choose one test value from each respective interval. So from the first interval, I want to choose negative 2. From the second interval, I want to choose 0. From the third interval, we can choose 3. And then substitute the test value into f prime x. And we want to take the sign of the final answer. For example, substitute negative 2 into f prime x. You can substitute into the first equation, second equation, or the last equation. Okay. For example, I want to substitute into the second equation. So negative 2 square minus negative 2 minus 2. We get 4. So just take the symbol, the sign of the final answer, which is positive. And then substitute 0. 0 minus 0 minus 2. We get negative 2 as the final answer. So just take the sign negative. And lastly, substitute 3. 9 minus 3 minus 2. We get positive 4 as the answer. So the sign is positive. Interval with positive sign is the increasing interval. And interval with negative sign is the decreasing interval. So do not forget to write down the conclusion. So the increasing interval are negative infinity, negative 1 union to positive infinity. then the decreasing interval is -1, 2. Second question, we are asked to determine the extremum points. So from the first critical value, -1, f -1. From the second critical value to f2. Substitute -1 into the original function. -1 power 3, -1. Minus 3, -1 square, 1. Minus 12 plus 8. We get 15. 15 is the y coordinate of the critical point. Second critical point. Substitute 2 into the original function. 2 power 3, 8. 2 square, 4. And we get -12. -12 is the y coordinate of the second critical point. These two are the critical point because we haven't determined which one is the maximum and which one is the minimum. But the question asks us to find the extremum. So now we must classify each critical point. To classify critical point as either maximum or minimum point, look at the y coordinate. 15 is above -12. Therefore, -1, 15 is the maximum point. And 2, -12 is the minimum point. C. We want to find the interval where f(x) is concave up or concave down. For concavity, we will have to use second derivative. So differentiate once again from the first derivative. We get 12x minus 6. 12x minus 6 equal 0. From here we can get inflection value, which equal to 1/2. From inflection value, create another table of 3 columns. Column 1 for the interval. Column 2 for test value. Column 3 second derivative, and the last column for concavity. Interval always start from negative infinity and ends with positive infinity. So first interval negative infinity 1/2. Second interval 1/2 positive infinity. Choose one test value from each respective interval. From first interval, I want to choose 0. From the second interval, I want to choose 1. Substitute 0 into the second derivative. We get the answer as -6. Just take the sign of the final answer. So, negative. Substitute 1 into second derivative. we get a positive answer. Negative is for concave downward, positive for concave upward. Or we can make a conclusion. Next, we want to determine the point of inflection. From the inflection value, substitute 1/2 to the original function. We get 1.5 or 3/2. So this is the inflection point. And finally, use the above information to sketch the graph fx. In order to sketch the graph, let's plot all the important points first. We have the maximum point at -115. Let's say here, -115. And then we have the minimum point at 2, -12. Let's say here, 2, -12. And we have the inflection point at 1/2, 3/2. Let's say somewhere here. From A, we know that the interval will start from increasing, decreasing, increasing. So the shape of our graph is like this. And then from the concavity, we know that the graph will start from concave downward and then concave upward. Increase, decrease, and increase. So increase, decrease, increase. Concave downward and then concave upward. So this is the correct answer.